Hello, I'm Gary Strunk, and in this presentation, I want to show the remarkable harmony there is between what the Bible says about our earth and what we find in digging in the crust of the earth. We're going to look at the geological column as it sits. We won't make this up. This is remarkable what you will be seeing, and then what we will be reading about in the scripture itself. Evidences of the flood by looking at the geological column. Now here is a typical example, a textbook example of the geological column. Life, according to them, goes way back at least 100 million years ago, that all this small sea life was buried. And then we work our way up into the dinosaur period, and then eventually, after many, many millions of years, we come up to the last period where you see mammals, human beings, as well as still some of the others. But that is the succession of life. That is strictly that is so filled with assumptions. And so let's see if we can't take it apart so that we understand what's really out there in our earth. Yeah, it said dinosaurs a few million years ago. Dinosaurs are 225 to 226 million years old. Now you'll find different estimates, but this is a legitimate statement. And I'm saying, nope. I'm not the first to say nope. In 2005, dinosaur fossils found with soft tissues, red blood cells, protein in the bones. It can't be millions because carbon-14, which measures organic life, in these tissues reads in thousands. Half-life of carbon-14 is only 5,730 years. If it were millions, there would be no carbon-14 left. So, and we found more than just one example. There are coming up several examples showing that it was not millions of years old. Here's what happened. This is from testimony from the scriptures. And behold, I myself am bringing floodwaters on the earth to destroy from under heaven all flesh in which is the breath of life. Everything that is on the earth shall die. Notice it didn't say sea life. This is on the dry land. Now before the flood, much of the waters we see above the earth were huge aquifers beneath the surface, from which a mist went up from the earth and watered the whole face of the ground. Genesis 2:6. But then the history of the flood. In the 600th year of Noah's life, in the second month, the 17th day of the month, on that day all the fountains of the great deep were broken up. I want you to notice that word, those lines. The fountains of the great deep were broken up. This is water coming from below, not from rain, but from below. And it was not beautiful blue waters. This was a slurry of mud, one belch after another. Some of those belches went clear across the planet. We're talking in huge dimension here. And so those aquifers were broken up. Life changed. The earth changed. What we see in the earth today is not at all what it was prior to the flood. And the windows of heaven were opened, and the rain was on the earth 40 days and 40 nights. Genesis 7:11-12. And the waters prevailed exceedingly on the earth, and all the high hills under the whole heaven were covered. Oh, that's an interesting statement, because you have some critics who say, well, the Genesis flood was just a local flood, just over in that land over there. But notice, it goes 15 cubits above the mountains. They didn't have mountains in those days like we have now. They had hills. But even if it's 15 cubits above, water seeks its own level. You can't have a local flood and hold it there. If it's covering the mountains or the hills there, it's going to go out and cover eventually the whole earth, which is what we have. We've got a flood. We have the evidence of a flood covering the whole earth. Yes, so the waters prevailed 15 cubits upward, and the mountains were covered. Don't think of mountains like we have today. Genesis 7. And further, The geological column, now this is what, as a proper description, not a biblical description, of a geological column. The geological column is a multi-layer blanket of sedimentary rock, of sandstone, limestone, and shale, deposited by water, which is found on nearly every landmass up to hundreds of feet. It can be traced across entire continents and correlated with similar layers on other continents. So, again, we're not talking a little local spot. We're talking about a worldwide flood in which the layers that you find in this continent match layers you find in another continent. And they are digging beneath the surface, underneath the ocean, and finding that there are strata or layers underneath the ocean too. Now, observations from the column. 95% of the fossils are marine. Only 5% are plants. Less than 5% are mammals, which would include us. But what I want you to notice, first of all, is what you find in the column, distinct speciation. There is no missing link. There isn't gradual progression from one kind of animal to another. This is a typical picture of what they call the tree of life. At the bottom, you begin with a single cell, in this case, an amoeba. Now remember that amoeba is so tiny you cannot see it with the naked eye. You have to have a microscope to see it. But they've just pictured here. And from this tiny little single cell, whether it's an amoeba, paramecium, or some other kind of protozoan, it's all imaginary anyway, but they picture this, and you can find dozens of these so-called trees of life if you go on the internet and follow those limbs that go up. You see distinct kinds of animals. You do not see different kinds of one kind of animal gradually emerging into a different kind of animal, because you don't. When you look in the under the earth and you look at the fossil remains, they're able to put a name to it quite different from this fossil and quite different from another fossil. And no matter how complex you make it, as in this diagram, that looks like, but they are still distinct creatures. The only place they really try to build a progression is up near the very top, where you see animals, monkeys, apes, chimpanzees, and eventually it becomes a human. We have no evidence of this. This is textbook assumptions. And you will find that almost all these fossils, largely from Africa, are all Pithecus. Pithecus means ape, whether it's Zangiopithecus or Australopithecus. There's all kinds of Pithecuses, but they're all apes. Life didn't come out of Africa and come up to Mesopotamia. Life began there after the flood in Mesopotamia. And this we can, no, not that part, we trace it in the other presentations where it came from the Mesopotamia. Now, notice this also. In the geological column, you still find amoebas in the column. You still find parameciums in the column, and they are virtually identical to these little one-cell creatures today. You have a single cell, but to multicell, and then to multi-cells. You have no 2-cell, no 4-cell, no 8-cell. How did you jump from a single cell that could multiply itself? Now you've got 2 amoebas, now you've got 4 amoebas, they multiply them. How do you suddenly become, do they have little creatures that are very complex, that has organs inside and a circulatory system? The idea of mutations moving from a single cell to a multicell is strictly an assumption. It's total theoretical. There is no evidence of it. And when you look at a unicell, a single-celled creature, you discover they are not simple. They are very complex. For example, here in a paramecium, you see little hair-like cilia around the outside by which it moves itself through the waters. It has a mouth through which food is taken in, and then where food leaves the body, and you have different digestive organs in here, and this is strictly a very, very simple schematic. They are very complex. There is no such thing as simple life. Life is remarkably complex and demands a creator to put it into existence. None of these little parts could exist outside the cell wall, and the cell wall itself is very complex. That's another lecture, but I'm fascinated by its complexity. Now, in the geological column, you have three different kinds of rocks, basic three different kinds. You have igneous, was from volcanoes, whether it's lava or pumice, the foam of lava, and basalt. Then you have sedimentary, water deposited. And notice, 75% of the rock around our world is sedimentary. It's water deposited. You have volcanic, yes, like in Hawaii. Then you have metamorphic, which is changed by heat and pressure. And so you have sedimentary rock, and then with the heat and the pressure, burns out any fossils that are in it and changes its shape, such as granite. That would be a metamorphic rock. But the most is the sedimentary rock. Sedimentary rock in the geological column is water deposited, laid down flat. Now that's the point I really want to make. Gravity lays them down flat underwater. And here's a funny example. From Bryce Canyon in Utah, if you were to trace these, you would find at once upon a time, here is a layer. And this layer covered the whole area. And then another layer came over that very quickly, and then another layer and another layer until it was all covered. This would all be flat. But then through water washing, rain, snow, wind, and probably a large amount of water that came through here, you have these strange structures left. But they were once upon a time laid down flat. You'll see more of that, for example, in the Grand Canyon. In the Grand Canyon, all of these layers, this strata, are flat, all the way to the top. Now, there's lots of erosion that has occurred since they were deposited, but it was all deposited flat here, then here, then here, and then a great amount of water, largely from the Middle East, from the mid-America, came down through here, washed it out while it was still fairly soft. It was not made there by the Colorado River. It was a gigantic washing. And you see this strata all over the world. For example, the Beachy Head chalk cliffs in England, you can see the strata there along those chalky cliffs. Or if you go to the White Cliffs of Dover, you can see that, no, you're not supposed to look at the airplane. You look at the lines underneath, and it was tipped up. Originally, it was flat, then tipped up a little bit on the right-hand side. Or let's go to Australia. Once again, these rocks are laid down flat as gravity lays them down. There happens to be no erosion, but I'll build on that point in just a moment. Or if you go to this area of Australia on the right, you have these fold mountains or fold sections, and won't spend much time, but let me give you an example. You see this, these are fold rocks, hills, formations in Australia, and you can follow the lines. As you follow the line here, it comes up here and then bends, comes down here. They're not broken at the tip. They are folded. So you had a large area here, you push it together, and then it folds while it was still fairly soft. If you did it while it was hard, it would break. And yes, I know you can, under heat and pressure, you can bend rock, but not like this. This is dramatic. And here's another example of dramatic, is the Alps. Whether that's the Swiss Alps or the French Alps or the Austrian Alps, they're still the Alps. And here's a picture of the Alps. You can see here the fold that exists in this mountain. This was formed by 400 miles of strata, 400 miles, and then it slid this direction, and you have these folds into 100 miles. 400 miles into 100 miles of mountain. Those are fold mountains. And as I was driving down in the southeastern part of the United States, I saw this along the highway. I don't remember whether I was in Tennessee, the Carolinas, or where, but I had to stop and take a picture. You can see here again, this is folding and probably slipping. At one time, they were all laid out flat, and while they were still fairly soft, up came one part of the mountain, and then all of these layers or strata folded down together. But you go to Argentina, there we have more of these strata, very pretty, depending on the minerals that were in that particular layer that spread out over the continent. And at the same time, you have strata that has been turned up on its side. But you can see how they were once flat as gravity laid them down. And I think God kind of had fun in making some structures for our amusement and for our amazement, the beauties that are in these various strata that once upon a time were flat, laid down underwater. Or we go to Hawaii. You can see the layering here. Maybe we can go in a little closer and you can see the strata that exists in these hills. By the way, while we're in Hawaii, let me remind you of something in Kilauea, Hawaii. There was a big lava flow 200 years ago. 200 years ago. But if you dig down into that deposit in the water, 4,680 meters, it measures 21 plus or minus 8 million years ago. You know, what's a few million years? 21 plus or minus 8 million years ago. But it happened only 200 years ago. And if you dig down 3,429 meters, it measures 12 million years ago. And if you go down 1,400 meters, it measures 0 million years ago, like it happened yesterday. Yet it only happened 200 years ago. I realize this is pillow lava, known to date earlier with the potassium-argon system that looks older than it was. But notice the gradations. And remember that the sedimentary rock was laid down by water. There are things, you cannot trust radiometric dating. There are too many flaws in it. And so we'll keep it at 200 years ago. You've already seen this smooth articulation between the layers, the strata. So once again, see how smooth it is between one layer and another? There was no time for erosion in there. And you see the same thing in the Grand Canyon. One layer right directly on top of another, directly on top of another. Lots of erosion since it was all laid down. But the lack of erosion between the strata is very, very significant in terms of time. You can see here how this was all one layer after another, very, very flat. And again, in the Grand Canyon, I don't want to spend more time there. It illustrates the same thing. We'll be talking about some other things there. Now, present day topography shows erosion. We've just seen the erosion in those other pictures. It shows tectonic movements, the earth movements, some rising in one place and dropping in another. There are very few really truly flat areas. So let's pretend that this was one of the early deposits, maybe a few million years ago. Yes, we'll say a few million years ago. And it laid right down on top of bedrock. Now here's a simple little illustration. You have bedrock, which is the Precambrian. Then you have the first layer several million years ago. See how nice and flat it is? And the next one above that is nice and flat. Second strata. But if it was there for millions of years, there would be erosion of the first layer, either by wind and water and earth movements, tectonic movements. And then the next layer would come in on top of that. But you never see this kind of pattern in the geological column. They're always flat. So here you have it on top. But if that was on the bottom, and then it was filled in with another layer that we'll say is flat on top, you would see these mountains underneath and the valleys underneath, but you never see that. They're always flat. So we'll put them underwater. However, there are mountains underwater, but they are mountains built on top of ground level. For example, over in Hawaii, you have the tallest mountain in the world. Not very tall above sea level, but it's very tall from ground level. From our Mount Everest on the top of the water goes up 8,850 meters. But Mauna Kea is 10,203 meters, but it doesn't measure from sea level like Mount Everest does. It measures from ground level. There are thought to be 100,000 uncharted mountains under the sea, but the important thing is that they have strata down there. They have strata in the very mountains we were just looking at. I didn't point them out, but they do. But here's probably one of my most enjoyable exhibits of mountains. I'm driving up the highway in Alberta, Canada, and I see these huge, beautiful mountains. Wow, they are so fantastic. But look at the strata in them. You can see the lines going down one side, the lines going up the other side. This is a geosyncline in which it's slumped in the middle, but if you raised it up in the middle, those lines would match each other. Big, beautiful mountains. And as I said, you can see the strata, you can see the layers. Once upon a time, those were all flat, and then they were uplifted. And there are marine fossils in the high mountains because, including Mount Everest, they were laid down by water and then pushed up later. There you can see a good example of the strata. And there's sea life in there. There's sea life in the Grand Canyon rocks. Now, as you looked at those big, beautiful mountains, I'm going to ask you, what is the average height of a mountain in the United States? Well, around 10,000. Let's say 2 miles high, 10,560. For the sake of our calculations, we'll say 10,000. And then we ask the question, how far from the west coast to the east coast of the United States? How far is it? About 3,000 miles. So now we divide that great big tall mountain 2 miles high, 10,000 feet, 2 miles. We'll divide that by the 3,000 miles across the United States. And we'll come up with a 0.00666, approximately 0.000 10,000ths of the 3,000 miles. Now let's put that in perspective where we can see it. If we took a table of 96 inches, I think we got a 72-inch table, but it illustrates the same thing, and multiply that times the 0.067 hundredths of the 96, and this is what you see. This is a dime. I'm going to put this dime underneath the 3,000 miles of the United States. You see that great big tall mountain there? You can't even hardly see it, can you? No. 3,000 miles across that little 10,000 foot hill. No matter how many mountains you have, you can't hardly see them. All God had to do was press them together just a little bit. In the east, they pressed together and they made the fold mountains. The Appalachian Mountains are fold mountains. But after they had cemented, hardened a little bit, from the west coast, whether he did it with the Pacific Plate or whether he did it with his hands, they jutted up these great big 10,000 foot mountains that you can't even see in comparison to the United States. Well, as I was driving up this Canadian highway, I saw this, look at that outstanding mountain. I felt I had really made a discovery here because as I get closer, if I can get around the other side, I could see the layering of this beautiful mountain. And I got closer and closer, and I thought, this is fantastic. I can begin to see it now. I've really made a discovery. But then, a little further, I discovered there was a sign pointing to Mount Rundle, about 9,675 feet. Apparently, somebody discovered that mountain before I did. In fact, I understand they have big, beautiful pictures of them all in frames. Well, get a little closer to home, and right out here, outside in Yucaipa, California, there are layering. There is, you can see up there, you can see the strata, how those hills have been flat at one time and then uplifted. You get a little closer and closer. Yes. Here we have an example, so close to my home, of what you see all over the West, what you see all over the world, people, all over the world. This is not just an isolated thing or an isolated flood. These layers were laid down by water all over the world. This was a huge flood. God destroyed all living things on the top of the earth, that is, all animal life. So, the Bible says, know this first, that scoffers will come in the last days, walking according to their own lust. Now, mind you, not everybody is a scoffer who believed in evolution, because that's what they've been taught in school. They've been taught falsehoods. And saying, where is the promise of his coming? That is the second coming. Because all things continue as they were from the beginning of creation. Well, that's an uniformitarian philosophy. It existed apparently way back there, that the rate of change that we see today is the same rate of change that we have seen throughout all history, or well before history, and so it must be millions and millions of years. No, this is what he says. For this they willingly forget, that by the word of God the heavens were of old, and the earth standing out of water and in the water, by which the world that then existed perished, being flooded with water, but the heavens and the earth which are now preserved by the same word are reserved for fire. Yes, God destroyed the world once by a flood. Next time he's going to destroy it by fire. And we have the rainbow as a sign to us that God will never flood the world again. So, may the God of heaven and the whole earth bless you with knowledge so that you may believe. The earth testifies to the Scripture's veracity, authenticity, truthfulness.